The last section in this chapter deals with an application of trigonometry, something that you'll see a lot if you ever take physics, okay, or any physics-based science class. So what these things are called are vectors, and vectors are visual representation of forces or moving objects. Okay? Vectors, since they represent things that are moving, they have two components. They have magnitude and a direction. Okay? Magnitude is, in the most general term, is the length of the vector. But what it really represents, it could be the size of the force or the speed of the object. Okay, the vector itself represents a velocity because velocity has a direction and a magnitude. Speed is a straight scalar value of how fast it's moving, and we find that by doing magnitude. Okay, direction is what it says. It's the direction. It's the direction of movement. It's the direction of movement. Okay, and this can be with respect to different things. It's usually with respect to the x-axis, but not always, okay? So here, this would be an example of a vector, okay? It's just an arrow. It starts here. It moves up there. So I know which way my force is moving. I know roughly how quickly it's moving by the length of the vector, okay? So this is a graph form. It's component form. Okay, we use these pointy brackets, and it's just like a point, only it's telling me which way it's moving left and right and how much it's moving up or down. So this one's moving 1, 2, 3 in the negative x direction, and it's moving up 1, 2, 3, 4 in the positive y direction. So this would be the component form of this vector. Okay. If I want to know its magnitude, I need to know how long this is. Okay. So if I want to find the length of this, really what I'm doing is I'm using my distance formula, but the distance formula is just, I cannot draw a straight line here. The distance formula is just a form of the Pythagorean theorem, which is why this is in this chapter. Okay, I'm just going to use Pythagorean theorem. This is 3, this is 4, which is the same thing I got from my component form, only now that I'm doing Pythagorean theorem, I'm going to it doesn't really matter what the signs are. I'll put it on there. Okay, this is negative 3, that's positive 4. So I'm going to do negative 3 squared. Make sure when you do this, whenever you square a number, it always comes out positive. Okay, so when I square negative 3, I'm taking negative 3 times negative 3. I'm getting positive 9 plus 4 squared, which is 16, equals 25. Square root of that would be the length here, so I get 5. So this has a magnitude of 5. Its direction is the angle it makes with the x-axis. So I can do kind of the same thing. So I've got this angle, okay, and this is negative 3 and this is 4. I want to know what this angle is, this angle that it would make with the x-axis. Or maybe I want to know what this angle is if I want to keep it standard. Okay. So there's different ways to express the direction. If they're just asking what angle does it make with the x-axis, then you really want to know this angle. Okay. Just so that we always start kind of at the same point. This is usually 0 degrees, and then we move from there this way. if they want to know, you know, an angle relative to the cardinal direction, so relative to north, you know, this would be north, west, south, and east. We can do it that way also. Just to keep it simple, we will stick with our right triangle representation. Okay, so I'll just have you find this angle, and then you can tell me a descriptor just so that I know what it is. So direction, we are going to use our inverse trig function. So I've got opposite. Well, I've got all three parts, so really you can do whatever you want. But let's see. If I'm talking about this angle, let's do a sine inverse. Okay. So sine inverse of opposite over adjacent, 4/5. Okay, and what does that equal? So we're gonna get an angle, and then I'm gonna have you tell me which quadrant it's in also. Okay. So we will do the sine inverse of 4/5. So 53 degrees. Okay. So our direction is 53.13. 53.13 degrees in quadrant 2. Remember, this is quadrant 1, 2, 3, 4. Okay, if you guys want a head start on pre-calculus, what we would actually do is we would just go from here, and since we're in quadrant 2, we're going to say that it would be, well, no, let's stick with this. Okay, 53.13 degrees in quadrant 2. Okay, and make sure your angle is always the one that it would make with the x-axis. If it was, so with, okay, we want the angle that it makes with the horizontal. Okay, by telling me quadrant 2, that lets me know that you're coming up this way. If we're in quadrant 3, I'd know you're down here. Quadrant 4, you're down here. Quadrant 1, you're pointing this way. Okay. So that's magnitude and direction. We can add vectors together. We can do it from our graph. Okay, so this vector takes a particle from here up to here. This vector v takes a particle from here to here. Okay, so if I'm going to add, so if I'm going to take vector u, so this is how you draw vector u plus vector v, that's the same as vector u plus v. Okay, and in this case, I would draw vector u plus v by going from my start point and drawing an arrow directly to where I end after going through both of those operations. This is vector u plus v. Okay, component form, the component form of u would be vector u is over 1 up 1, 2, 3, 4. The component form of vector v is over 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5, 6. So if I'm going to add these with component form, I just add the horizontal movement. So over 1, over 5, that's a total of over 6. Up 4, down 6, that's a total of down 2. This would be u plus v. Okay, and I can check that on my graph. Am I going over 6? 1, 2, 3, 4, 5, 6. Am I going down 2? 1, 2? Yes. So this would be your sum. Magnitude of the resulting vector. So if I want magnitude of my resulting vector, that's the length. How long is this? Which is just Pythagorean theorem. 6 squared plus negative 2 squared. 36 plus 4 is 40. Square root that. This turns into 20 and 2. This is 4 and 5. This is 2 and 2. So I get 2 square root 10 for the magnitude. Direction relative to east. Okay, now this is where we can have different directions here. Relative to east, since east is this direction, I want this angle here. Okay, so I'm going to make my right triangle. I'll make my right triangle a little different color here so we can... Okay, here's the right triangle I'm dealing with. Okay, I want to know this angle because I want to know relative to heading east, which way am I headed? Well, this is 2, and this is 6. So I've got tangent. Okay, so I'm going to do tangent inverse of opposite over adjacent. So 2 over 6, which is the same as 1/3. Figure out what that is. So I don't want this thing up. Okay, so I want the tangent inverse of 1/3. So it's 18.43 degrees. And I'm headed south of east. Okay, so this would be straight east. I'm headed a little bit south of that. So this would be south of east. 18.43 degrees south of east. Okay, if I want the direction relative to south, I'll make a green triangle for that. So this is south. Okay. So if I were heading this way, that would be south, but I'm not heading south, so I want to know this angle now. Okay, how much east of south am I headed? So I need to know this angle. Well, in order to find that, this is 6, this is 2. So I'm going to do tangent inverse of 6 over 2, which is 3. So tangent inverse of 3. Okay, 71.57 degrees. Is that right? No, 71, not 41, 71. 71 degrees east of south, or you could say, yeah, we'll just say east of south, okay? Some people would say south by southeast, but we'll just say east of south to keep it straight. If you notice, these two are really just the two angles that I get in my triangle, okay? So I could have taken, if I do one, I could find the other one by taking away from 90. Okay, and that's all you'll be expected to do with vectors, but if you ever take physics or certain other science classes, you'll see these again.